Now our next topic is midpoint theorem. Midpoint theorem. So statement. The segment joining midpoints of any two sides of a triangle is parallel to the third side and half of it. Midpoint theorem is the segment joining midpoints of any two sides of a triangle is parallel to the third side and it is half of it. So what is given? In triangle ABC, point P is the midpoint of segment AB and point Q is the midpoint of segment AC. This is your given part. In triangle ABC, P is the midpoint of segment AB and Q is the midpoint of segment AC. What you have to prove? PQ parallel to BC. Segment joining any two midpoints of any two sides of a triangle is parallel to the third side, means you have to prove that PQ is parallel to BC. PQ is parallel to BC and it is half of it, means PQ is half of BC. So you have to prove that PQ is parallel to BC and PQ is half of BC. PQ is parallel to BC and this PQ is half of BC. This you have to prove. Now construction. Produce segment PQ up to R such that PQ is equal to QR and draw segment RC. Now suppose this is your triangle ABC. P is the midpoint of AB and Q is the midpoint of AC. Now construction is produce segment PQ up to R such that PQ is equal to QR. This is your construction. Now proof. In triangle AQP and triangle CQR. In triangle AQP, in triangle AQP and triangle CQR and triangle CQR. Segment PQ is congruent to segment QR construction. Segment PQ is congruent to segment QR. It is construction. Segment AQ is congruent to segment QC. It is given because Q is the midpoint of AC given. So segment AQ is congruent to segment QC and angle AQP is congruent to angle CQR, vertically opposite angles. Vertically opposite angles. Therefore, triangle AQP is congruent to triangle CQR by SAS test of congruency. So in triangle AQP and triangle CQR, segment PQ is congruent to segment QR. Construction. Segment AQ is congruent to segment QC. It is given. Angle AQP is congruent to angle CQR, vertically opposite angle. Therefore, triangle AQP is congruent to triangle CQR by SAS test of congruency. If two triangles are congruent, then their corresponding angles and corresponding sides are congruent. Therefore, angle PAQ is congruent to angle RCQ. Now, these two triangles are congruent. Therefore, angle PAQ is congruent to angle RCQ. Is congruent to angle RCQ by CACT. And segment AP is congruent to segment CR by CSCT. These two triangles are congruent, therefore their corresponding sides and corresponding angles are congruent. So angle PAQ is congruent to angle RCQ by CACT and segment AP is congruent to segment CR. Reason is CSCT. This is your equation 1 and this is your equation 2. Now from one line AB is parallel to line CR, but this PAQ and angle RCQ, these are which type of angles? Alternate angles, and when alternate angles are congruent, lines are parallel. Lines are parallel. So from one line AB is parallel to line CR. Reason is alternate angle test. These are alternate angles, and when alternate angles are congruent, lines are parallel. So from one line AB is parallel to line CR, alternate angle test. And from two, segment AP is congruent to segment CR, AP is congruent to CR. It is from 2. But now segment AP is congruent to segment PB is congruent to segment CR. Now segment AP is congruent to segment BP because P is the midpoint given. Therefore, AP is congruent to BP. Now AP is congruent to RC also by CSCT. Therefore, AP equal to BP equal to CR. Therefore, segment AP is congruent to segment CR. Now segment AP is congruent to segment PB is congruent to segment CR, and PB is parallel to CR, and PB and segment PB is parallel to segment CR. Therefore, quadrilateral PBCR is a parallelogram. Therefore, quadrilateral PBCR is a parallelogram. Why? Because a quadrilateral is a parallelogram if a pair of its opposite side is parallel and congruent. If a pair of its opposite side is parallel and congruent. So, quadrilateral PBCR is a parallelogram. If it is a parallelogram means seg PQ is parallel to segment BC. Now, PBCR is a parallelogram. Therefore, PR is parallel to BC. But for PR, we can write as PQ because P dash Q dash R. So, PQ is parallel to BC and PR is equal to BC. Opposite sides of a parallelogram are parallel and congruent. So, quadrilateral PBCR is a parallelogram. Therefore, sec PQ is parallel to sec BC and PR is equal to BC. Opposite sides are congruent. Opposite sides are congruent. But PQ is half of PR construction because construction is PQ is equal to QR. Therefore, PQ is half of QR. Therefore, PQ is half of PR construction, but PR is equal to BC. But PR is equal to BC. Therefore, PQ is for this PR, PQ equal to half of BC since PR equal to BC. Hence proved. So, what is your midpoint theorem? The segment joining midpoints of any two sides of a triangle is parallel to the third side and half of it.